Commander Brian O'Connor, leading the crew out.
Launch day for STS-40, the first mission dedicated to studying the human body and microgravity. In Columbia's cargo bay, a reusable research facility called Spacelab. A tunnel led crew members from Columbia's main cabin into the lab. Here they conducted a series of life sciences experiments designed by a team of international investigators, studying in unprecedented detail how the body adapts to weightlessness, how it readapts upon return, and the mechanisms regulating these changes. Crew members took turns wearing a neck chamber to measure the response of receptors that help govern blood pressure. The work seems to confirm that this blood pressure regulating system is impaired in space, which might help explain the lightheadedness astronauts experience when they stand up after landing. Data was also gathered on variations in blood flow and flexibility of vessels in the leg. This is thought to contribute to the body's inability to maintain normal blood pressure immediately upon return to Earth. Samples collected over the course of the 9-day flight are being analyzed to determine whether changes in hormone levels may be part of the reason bone and muscle deteriorate in space. Time spent pedaling a stationary bike served a dual purpose, providing information on exercise capacity and microgravity, as well as heart and lung functions. The distribution of blood in the lungs did not appear to change as predicted, a surprise scientists are currently evaluating. A number of other studies tested the theory that visual perception, in conjunction with changes in the inner ear, contribute to motion sickness symptoms most people experience when traveling in space. But measuring changes and even determining their causes is just a beginning, according to mission specialist Dr. Ray Seddon.
What we really have to do is decide whether or not we have to reverse some of these changes, whether we have to develop countermeasures, for instance, for the loss of calcium that we see from the bones, the loss of fluid from the body. Of course, this mission was for only 9 days, and you can never say that what happens in 9 days is all that will happen in 3 years in going to Mars. There's no way that you can evaluate the countermeasures that you develop. They require a space station, and that's why we think space station is so important for life sciences research.
Wherever possible, the research aboard Spacelab was done with an eye towards earthly applications.
There are a lot of people who don't regulate their blood pressure properly, and they have high blood pressure. What can we learn about the changes that take place in weightlessness, about regulation, that we can put to use here on the ground? People, as they get older or as they're bedridden, tend to lose calcium from the bones. What regulates that, and how is it the same, and how is it different from weightlessness? And if we can counteract it for astronauts going to Mars, perhaps we can counteract it in women as they get older and developing osteoporosis. So there are a variety of things that I think we hope to gain from a mission such as this.
Spacelab Life Sciences-1, the most comprehensive study of human adaptation ever undertaken, enhancing our future both in space and here on Earth.
Touchdown.
Roger that, Columbia. Welcome back, and congratulations on a super flight.